Question 5 in the 2016 paper, I think, so probability. In an archery competition, the team consisting of John, David and Mike will win first prize if at least 2 of them hit the bullseye with their last arrow. From past experience, they know that the probability that John, David and Mike will hit bullseye on their last arrow is that 1/5, 1/6, 1/4. So the probability that they won't hit the bullseye for John is 4/5, for David it's 5/6, and for Mike it's 3/4. Complete the table below to show all the ways in which they could win the first prize. So this way 1, this is the arrangement of their last dart. So John hits with his last dart, David hits with his last dart, Mike misses with his last dart. So you could also do it that John hits with his last dart, David doesn't, but Mike does. Or you could do that John misses, but David and Mike both hit it. Or another option is that, because it says at least 2 of them, another option is that all 3 of them hit it. Hence or otherwise, find the probability that they will win the competition. So either of these ways is acceptable to them. So this way or this way or this way. So the probability that John hits it is 1/5. And you need David to hit it. So what's David? David's 1/6. But then you need Mike to miss, which is 3/4. You'd work that out. Or John to hit, so 1/5. David to miss, so David's 1/6 chance of hitting it, so that means he's 5/6 chance of missing it. And Mike to hit, which is 1/4. Or this guy can miss, so 4/5. David to hit, so 1/6, and Mike to hit by 1/4. And then John to hit, and David and Mike to hit. Sorry, that's 1/5 there. So 1/6 by 1/4. So multiplying all of that together, if you want to do it out step by step, that's okay. But multiplying all of that together gives you 13 out of 120. So not great. Not a great chance. Now this next part, A and B are represented in the diagram. They're 2 events. The probability of A intersection B is 0.1. The probability of B but not A is 0.3. And the probability of A less B is X. Write the probability of A in terms of X, and hence or otherwise find the value of X for which the events are independent. Now, there's a formula for independent events. It's not in your tables, unfortunately. So if the events are independent, then the probability of A intersection B will be equal to the probability of A multiplied by the probability of B if the events are independent. And just remember, independent events are events that have the outcome of one has no effect on the outcome of the other. So what's the probability of A first of all? The probability of A is X, this amount plus this amount. So okay, so plus 0.1. Now, so if we look at this formula, probability of A intersection B is equal to the probability of A multiplied by the probability of B. So they're already written in decimal form, so that's why I don't need to put them over anything. So the probability of A intersection B, as I know, is 0.1. It's given to me there. The probability of A is X plus 0.1, and the probability of B is 0.4. These two added together. So multiplying out and solving, And then 0.1 by 0.04 is 0.04. So solving for x gives you 0.15.